Hey, welcome everyone. This is the fourth talk in a series of Design Tech Talks, the Design Tech Talk series. We will be taking questions on Go/Design Portal, and specifically today I'm going to talk about design for testability. I guess we can ask questions on the design portal, but also if you want to just ask questions, just come up to the microphone and interrupt me at any point. It's cool with me. Anyways, let's get started. So how many of you guys are interested in testability? How many try to write tests? Oh, most of you guys. Awesome. And how easy do you find that? Not so easy. All right. I'm going to kind of try to, this is my opinion why it's not so easy. So here's how it kind of works. You got the software engineers, you got the QA, and you got the test engineers. And here's what most people think about how the process should work. So first, you got the developers. It's red because that's where they put the bugs in. Then you have a separate organization who tries to go and do manual tests and do exploratory tests and so on. And at some point, you get kind of tired of it all, and you say, well, I want to automate this process so that I don't have to do it over and over again. So you get test engineers, and they try to write some automation tests. And they try to write a test, and it just doesn't go. It's really, really difficult to do that. So people start looking for all these kind of magical tools that you can, run over your code base, and magically it becomes testable, right? And so these third-party tool vendors come to you and they'll tell you, oh, if you only use Mercurial or Selenium or whatever, like all of your testing needs are going to be solved. But we know better, don't we? So there is no testing magic on this stage. The thing is, and this is kind of hard for people to get used to, is that all the testability magic happens at the software development portion of the whole development process. So you, as a software developer, are responsible for not only making sure that the code is testable, but in my opinion, also you're responsible for the unit tests, which is the lowest level test that we have. And then the test engineers are more kind of responsible for the automation test from end-to-end testing, where you are pretending to be a user, right? So as a software engineer, you want to know that your individual methods work, whereas as a test engineer, you want to know that the overall system works properly. So usually when we come to a team and we say, hey, we should do some testing, people say, well, we don't test because, and they give you lots and lots of excuses. So I'm going to kind of quickly go over the excuses before we jump into the good fun stuff of actually talking about how you design for testability. So I'm going to break them down into two parts, which is the valid excuses and the common misconceptions. Now, the valid excuse for not testing is that you have legacy code. Now, I kind of used to think that that's a valid excuse, but now I'm thinking, no. Like, you have a legacy code, but it's probably you who wrote it. And if it's not you, now you inherit it, and you got to deal with it. So you got to clean up your act. Like, I know the code is not testable, but you can't continuously use that excuse forever and say, well, it's legacy, and therefore I'll never test it, right? So you just got to suck it up and fix it. And I'm really quickly going to go through all of these. They're all common misconceptions, and the talk is really about design, not necessarily about the misconceptions. I'm just going to pass through them. The other end of the spectrum is that when you write UI, tests are a lot more difficult to write. They're not impossible, they're a lot more difficult. But here's the thing. Here is one valid excuse that you have for not writing tests. And whenever I talk to people, nobody ever says that. Anybody wants to take a guess what the valid excuse is? You don't know how, right? That's the valid excuse. Like, hey, I don't know how to do this. Because you know what? Testing is a skill. It's a skill like any other skill. You've been writing code for, some of you probably for 20 years or so. And so you're really, really good at writing code. And so when you first time come around and say, hey, let me write a test, you actually discover that you don't know how to do it, and when you start writing it, it goes really, really slow, and so you compare your highly efficient writing code without tests with, I'm learning a new trick here, writing with tests, and you say, well, clearly this is not a good idea because I'm really slow. But it turns out that with practice, you get much, much better at it. So today we're going to specifically talk about, this don't know part, what makes the code hard to test. So here's another question. How do you make your code hard to test? Anybody? I know some of you have been listening to me earlier, so you probably already know the answers to these questions. But surprisingly, we are really, really good at making code hard to test. Anybody disagree with that statement, that we're not so good at it? I think we're fabulously good at it. The trick is we are so good at it, we don't even recognize when we do it. It's kind of like innate ability that we have to make code impossible to test. So there are four biggest untestables that I call them, and this is what we're going to talk about today. They are the places where you place your new operators will totally determine whether your code is testable or it's hard to test. And how many of you guys actually actively think about, where I'm going to place the new operator inside of my code base? Okay, some of you. Well, you are probably the guys who do testing. What about the rest of the team that you work with? Do you think most of them think about the new operators, or they're just like, oh, I need a new object, let me new one up? The other one is working constructors. This is another problem that causes a lot of trouble from testability point of view, and we'll kind of go into that in a second. Global state. How many people think that global state should be abolished and you should never ever have global state in your code base? Okay, how many people think singletons are a good idea? How many people realize that the two are the same? All right, awesome. Some of you. A lot of times I ask this question and people say, yeah, global state, not a good idea. This was already proven a long time ago. And I said, do you use singletons? Oh, yeah, we love them. I'm like, do you realize singletons are global state? And they look at you all weird like, no, it isn't. It's hidden behind a private constructor. And lastly, it's law of Demeter violations. So let's go through all of these kind of in detail. And by the way, if you have any questions, feel free to stop me. I love taking questions. Can you actually get in the microphone, though? So that the rest of you, us can hear it?
So what does Demeter violation mean?
Law of Demeter will have lots of slides on it, so just hold it, we'll get to it. So let's talk about the new operator, why the new operator will kill you. Testing, right? You got a test driver. This is your JUnit, your JavaScript test unit, or whatever you happen to be using for your test driver. Then you have your class under test. This is this thing that I'm trying to prove that it works properly. And so you apply some stimulus to the class under test, and then you assert that the class did the right stuff, and that's kind of it, right? I mean, what is there to testing? Why are we even having this meeting? Why are we talking about this? What am I missing here? Well, what I'm missing is this is a really small portion of the whole problem. Really, the problem is that the class under test has dependencies. And now the class under test just got bigger. So if you're trying to test something that's a leaf, like math.absolute value, piece of cake, right? Nobody's going to have a hard time. But if you're trying to test something more complicated, like the main method of your application, not so simple anymore, right? Okay, so class under test has dependencies, but it gets worse. Those dependencies have other dependencies, and they have other dependencies. And pretty soon, you have your whole of application entangled inside of your test, and you can't seem to figure out what are you doing. So what we're really trying to do is we're trying to make the dependencies go away. Just kind of disappear, right? Fade into the background. And we're trying to replace the dependencies with friendlies. Now, before we can do that, I want to point out that I have drawn three different kinds of arrows. There is the arrow with the dot in the front, which I call the object instantiation. This is where your new operator lives, right? There's the arrow without the dot, which is that the class under test received its collaborator just from some other location. And then there is the dashed line, which is that the friendly has just kind of reached into the global space and just pulled a singleton out of nowhere. And those three things will make it difficult, or two out of those three things will make it difficult to test. Really, those are the three ways you can get a hold of a collaborator, right? You can either make it, you can either be passed into it, or you can reach into a global state to get a hold of it. Now, when I say friendlies, a lot of people think that I immediately mean, oh, you have to have an interface, and you have to have multiple implementations, and so on. And that's not necessarily the case. Because a friendly, for example, can be the real object that I've already tested somewhere else and already behaves the way I expect it. And so when my test fails, I know not to look for the problem over there because that object is already tested. But the most important part about the friendlies is that from a test, I need to be able to control the instantiation process. Let me give you an example. Suppose a friendly is a cache, and I want to simulate a cache hit and a cache miss. Now, in production, I'll probably have a cache with several gigabytes worth of RAM, And so simulating a cache miss or cache hit is going to be really, really difficult with caches that size. Not to mention that running that kind of a test is going to be difficult because you're going to try to allocate all this memory. So if the class under test just simply says new cache size 5 million, you're going to not have a good fun time testing this thing, right? But if you control the instantiation of a cache and you say, well, let me make a cache, and we'll make the cache size 1, and then let me pre-populate some values into it, then I can control, when the cache hit happens, when the cache miss happens. So the key over there is the friendly could be a mock, but more likely it's actually going to be the real class that's configured in a test-friendly way, something that brings out a scenario that you wanted to point out. And we'll talk about the global reaching into the global state and getting hold of a singleton in a later point of the slides. Okay, so in order to replace the friendlies, you need to have something called a seam. And seam, if you think about it, all it is a virtual method call. So in Java, all methods are virtual. In C++ world, right, you have to have the virtual method call over there. But really what it is that you can control the path flow of your software purely by the way the application is wired together, right? So it's not that you have an if statement inside of your class under test that says if you're running under test mode, go to the fake cache instead of the real production cache, right? It's that you wired the application together with a fake cache or a fake authenticator or a fake file system or a fake database or in-memory database or what have you. So seams really mean that you control the instantiation, not that you have virtual methods. Because, for example, I could have a cache interface, and then the class under test can instantiate a concrete implementation of that interface. And from a testability point of view, it doesn't help me. Like, yes, I have a virtual method over there, but the fact that it instantiated a concrete class negated all of the benefits of having an interface. So really, controlling the order of instantiation or the way you wire things together is the whole trick to testability, and especially the way you have to think about the new operators. So here's the crazy idea I'm proposing here, that the object graph construction and lookup and the responsibility of the business logic being your if statements, your loops, your conditionals, those two pieces are really separate. They have nothing to do with each other, and you need to break them up, right? You should have classes that either have business logic, you mean your ifs, loops, etc., or classes that have new operators, which are what we call factories, which wire the pieces together. Then it gives me a freedom from testability point of view, because I can either decide to test the business logic by wiring it up in a special way from a test, or I can test the factory to verify that the factory wired the objects together without actually running the code, right? I can verify that a proper large cache got instantiated without actually running through all the cache operations. So those two pieces are really, really important. And if you use dependency injection, because this is really what it's asking for, you need to use, well, you don't have to use, but it's highly recommended you use some kind of a dependency injection framework that does this for you, this wiring. It really makes life easier. The one we like to use at Google here is called Juice. How many of you guys use Juice? All right, most of you guys. Awesome. The rest of you guys are what, C++, Python? C++? I'm not sure what is there for C++. Russ, do you know? All right, we don't know what the story is for C++. But I heard that there is some kind of a magic stuff available for C++. A lot of times people will argue that in dynamic languages that allow duck typing and monkey patching, that dependency injection is not needed because you can kind of replace the dependencies. But it turns out that monkey patching is just modifying global state, because code is really global state. And if you're modifying global state, you're back to square one in terms of all the problems that you have with global state. All right. So really what you want to get to is you want to place all of the new operators inside of the test and then push the whole wiring to the other side so that the class under test is sandwiched between, on one side, the test driver, which is your test, and on the other side, between your friendly thugs. And between the two of you guys, you can really beat up the guy in the middle and make sure that he does the right stuff, right? So let's talk about some examples. Suppose you see this. Let's say you're doing a code review for somebody, and suppose you see this. What would you comment? What would you say in terms of testability? Like, yeah, good, no, no good. What can I do? Well, if you wanted to test this thing, right, you say, well, let's make a new house, but like, darn, I'm stuck with the kitchen and the bedroom and everything else that comes with the house, right? And if you wanted to say, well, I want to test the house, but really it's a one-bedroom condo, no way for you to influence the way the objects are wired together. So the suggestion is use dependency injection and say, well, actually house depends on kitchen and bedroom, and it's really not the business of the house to know how to construct these things. Somebody just kind of hands them to you, right? If you think about it, have you ever seen a house that constructs itself? But I only seen a contractor that constructs the house for me, right? Similarly, like with dependency injection, right? Constructors, they're kind of misnamed because they mean like, oh, it's the thing that builds the object. But really, they're not in the business of building objects because they're really only in the business of kind of saying, these are my dependencies. You know, this is what I need to get my job done. So now, if you have this, the test becomes really nice because you can say, well, I want a house, but I really want a dummy kitchen and dummy bedroom because I want to simulate what happens when the kitchen's on fire. So I can insert a kitchen on fire class in there and then make sure that the fire alarm goes off in my house. Here's another example. Look at that. I am stuck with a 12-hour workday. That's great for production, right? But I really don't want my test to run for 12 hours, right? So what you really want is be able to say, well, actually, I just really want the hours and the boots. But really, you should even take it a step further and say, the garden shouldn't even ask for the pieces. The garden should just ask for the objects directly. So here's the case where the constructor is kind of doing work, and it's kind of a mixed thing. Like the garden says, well, I need the gardener, but then it goes and configures the gardener in a specific way. And again, the problem becomes that from a testing point of view, you have tests that run really, really slowly. And so, again, the solution is break this thing up. Say garden is only asking for the gardener. There's a provider somewhere in Juice that knows how to configure the pieces together, wire them up, and then provides that to the garden. Does that make sense? All right. And from a testing point of view, right, you can then say, well, I want to have a 1-minute workday to kind of simulate in a much simpler way what the work is. All right, so let's talk about the cost of construction. We kind of talked about the constructors, right, with the new operators where you place them, but now let's talk about the cost of construction. So to test the method, you first need to instantiate an object. Remember I said that we want to be able to wire the objects in a specific way and then apply some stimulus to it and then assert the output. You can't assert a stimulus before the objects are wired together, right? And you can't assert the output before the stimulus. I mean, they have a specific order, and you can't change the order in which they happen. Like, you don't have a choice from a testing. You gotta wire them, assert the stimulus, and then assert that the right stuff is happening. So if your constructors get executed during the wiring phase of your test, right? When you're wiring the pieces together, your constructors are running. So if you put any kind of code inside of the constructor, such as code that goes into the file system and tries to read a configuration file or anything along those lines, that code executes every single time you try to wire the objects together. Now, maybe you can survive a single test where you can mock out the file system or something like that. But if you look at the number of times you construct the object versus number of times you're actually asserting some behavior on it, you will find that you are reusing the class, not just inside of, if it's a class X, not just in the X test class, but also you're reusing it as dependencies for other classes and so on. So the class can easily be used in a lot more places than the number of tests that are available for that class. And so for that reason, if you have something in a constructor that is hard to execute in isolation, a lot of people will be suffering that are dependent on your class. So when I look at other people's code, the first thing I go for is I look at the constructor and I say, does the constructor do anything? If the answer is yes, I shiver because I know it's going to be really hard to get this thing instantiated and wired up in the correct way so that I can apply some stimulus to the classes. There's other problems with constructor, and it is you cannot override constructors, right? So you cannot say, well, call the constructor, but don't do this action over here, right? I can override a method and say, well, do everything else, but don't call this method over here because that one is expensive or something. But I can't do that with a constructor. It's all or nothing proposition. And if your class has a very deep inheritance hierarchy, well then, not only do you have to deal with your constructor, but everybody else's constructor. And so, because the tests have to successfully navigate the constructors over and over and over again, anything you put over there is going to be greatly multiplied. Even the smallest amount of pain is going to become a huge monster for you to fight with. So the solution to that is you want to really do as little work in a constructor as possible. In my personal opinion, you should do nothing else but assign your dependencies to your fields. Nothing else, just that much. So let's look at an example of a constructor that does work. Here is a car, and a car says, well, I need an engine, right? I mean, it has a field engine. But instead of asking for the engine, it says, well, give me the configuration file, and I will go into the configuration file, read it in there. And from there, I'm going to extract the model number, and then I'm going to use to build the factory to build the engine that I'm interested in. Anybody see a problem with this? Well, you might be laughing, but code like this actually exists, right? I mean, it wouldn't be so funny if it wouldn't be so true. But it also is kind of strange. Like, maybe you've seen the movie Transformers, but like, have you ever seen the car that can assemble a factory, which then assembles the engine for the car? Like, that's pretty crazy, right? Cars don't usually assemble factories. But somehow when we don't deal with real objects like cars and factories, but we deal with like abstract classes, it seems okay for an abstract class to be constructing another class inside of our code base. So from testing point of view, yeah, maybe you can go and write a specific engine configuration file into your file system, which is going to mean that the test is slow. But really, you really don't control the whole process, right? So what you want to do is you want to simply say, give me the thing that I need, which is the engine. So the other trick I do when I look at classes is I say, okay, look in the constructor and make sure there's no work in there. Look at the constructor to make sure that all it's doing is assigning its dependencies to the fields. And then I'm going to do one more thing, and that is I'm going to check to make sure that the dependencies that you actually save into your fields are actually the dependencies that you truly need. And that's where we're going to get into law of Demeter violation in a second. So there's one more piece to looking at the class. Right. So if you have it rewritten in this particular way, testing becomes really easy because you can just say, make a new car, and the car says, well, I need an engine, and then you have a freedom to instantiate any kind of engine you want in your test. Now, one thing I'd like to point out is that if you follow these kind of guidelines, the thing you're going to discover is that new operators are really prevalent inside of your tests. Like, tests are filled with them. The other thing that the tests are filled with are nulls. Because null basically says, suppose you're trying to instantiate a house. Well, house says, well, I need a kitchen and a bedroom. And the kitchen says, well, I need the dishwasher, I need the refrigerator, the stove, the electricity, the plumbing, and so on and so forth. And the refrigerator says, well, I need the plug and the water supply and the water filter and so on. So if you were forced to instantiate every single object all the way down, you might be instantiating a huge number of objects that you don't actually need. What if you're trying to test a method on a house that simply says secure, which means lock all the doors and lock all the windows? The kitchen really doesn't come into play. So it would be really nice if I could just say, make a new house, and oh, by the way, when you're asking for a kitchen, just here is a null, right? It's none of your business. Don't worry about it. When the test breaks, this is not the problem you're looking for, right? Don't go to the kitchen because that has nothing to do with this. So nulls is a nice way to tell the reader that this is really not important for you, right? This is not what I'm testing. So your tests really are filled with new operators, and they're filled with nulls. Whereas if you go look at a production code, you should be really devoid of new operators, and preferably you should have no nulls, because you shouldn't return a null value and then check for null value, because if you dereference it, it will blow up. You should instead return null value objects, right? Don't return a null for the number of windows, return an empty array, right? Don't return null for, hey, I don't have a logger. Instead, return a null logger that if you log something, it just goes into a void. So production code, no no new operators, no nulls. Test code, lots of news, lots of nulls. Here's another example. This kind of touches on global state. Suppose I want to, and also doing work in a constructor. Suppose I wanted to instantiate this, and of course this automatically tries to instantiate a socket. From a testing point of view, this is going to be a real headache. And the solution is always the same. I feel like I'm sometimes selling snake oil. What's your problem? The solution is dependency injection. Right, so we have a problem. And again, the solution becomes simply ask for the socket, and then I'll be able to provide you with a fake socket or in-memory socket or socket that's already configured in a particular way that makes it easy for me to test it. All right, let's talk about global state. And the best quote I have for global state that it's insanity. And it's a good definition of insanity is the repeating the same thing and expecting a different result. And global state allows you to become insane specifically for this reason, because you keep doing the same thing and it always behaves differently. Let me demonstrate. Suppose I have a code like this. I have a class X, and I have a method on class X that says do something, and that method returns an int. And I'm going to say new X do something, and new X do something again, and I'm going to assign them to A and B. What do you think? Should A and B be equal or not? How many people vote for A and B being equal? Okay, how many people vote for A and B can be different? Okay, can be different, and let me ask a different question. Is it a good idea for A and B to be different? It's not a good idea at all. Yes, they can be different. What it really means is that your code depends on global state. If they are different, here what's really happening is this, that you're instantiating a new X, that might instantiate other objects, that's perfectly okay. And then you instantiate X again, and that might instantiate the same set of objects in the same exact way because it's only one kind of code base. And the only way that A and B are not different is if those two objects share some global state. If that's the case, then the two are not equal. And this is very problematic from a testing point of view, because what it means is that there is some stuff that you don't know about outside of the definition of your test. And that stuff can be persisted, and then when a subsequent test runs and it's doing something, that global state can influence it. And therefore you can get a different behavior. Why do you care? You care because suppose you have 1,000 tests. And you are in a situation where when you run the test individually, they all pass. But when you run them together, they don't pass. It kind of makes it really hard to debug. Now, to make the situation worse, suppose your tests are slow. I know we should write fast tests and all that stuff, but suppose your test suite takes 2 hours, and the test that fails is on the end of the 2 hours, and if you run the test in isolation, it passes. Good luck debugging it. Because every time you hit your debugger and you put a breakpoint, you got to wait 2 hours till it gets to the right state so that you can simulate and figure out what's going on. So global state, from a testing point of view, is a real problem. If you think about it, what tests are a small instantiation of your application over and over and over again, right? And when you instantiate a small chunk of application, you want to make sure that the only thing that affects the execution of it is what the test told it to do, right? There should be no external factors that are affecting it. So these external factors will basically cause flakiness, will cause that the order of the test execution will matter, and then it will also mean that you cannot run the test in parallel. All of those things are very undesirable, right? We kind of all agree on that. There's a couple of hidden state inside of your JVM, and that is system.currentTime, right? That's a hidden state. New date, which by the way uses system.currentTime, and of course math.random. And I'm going to argue that if you try to test code with any of these functions, you're going to have a real hard time testing it. And that the code is probably going to be flaky. Even if you kind of make up something where you say, oh, well, I'm going to execute this piece of code, and it's going to call new date, and I'm going to instantiate a new date, and I'm going to assume that the date that the test executed will be later than the other one. It's going to kind of work sometimes, and then once in a while it's going to be flaky and it's not going to work. But there is a third problem with global state, and this is my favorite problem, and this is the real problem that I really think is the biggest reason not to use any, and that is that the API lies about what it needs. So let me show you an example. Once upon a time, there was a project I was on, and I wanted to test to see how credit cards work. So I said new credit card, and I had to type in a real number. So I typed in my credit card, and I said charge $100. And finally, a month later, I got my statement, and guess what? I was out $100. And I said, well, wait a minute. How can that be? How does the test know how to connect to a gateway, how to talk to some real service over there, put a certificate, exchange money? It's not just like out of thin void that the test can do these things, right? You have to tell the test on how to do all these things. Well, turns out that these tests never actually passed in isolation. It always would only pass in production code. When you would run it together, the test would pass. When you try to run it by itself, the test wouldn't work. So let's have a look as to what the problem is. You run it by itself, and it throws a null pointer exception. And you have no idea why that is. Because I didn't pass any nulls, so why is it throwing null pointer exception in here? So you go talk to the older and wiser people on the team, and you say, hey, you wrote the credit card. Could you tell me why it's not working? And they usually say something along the lines, only if we had documentation, this wouldn't be a problem, right? But it's really missing the point, because the API should be self-documenting. But really, you chat with this person, and the person says, well, the reason why this is failing is as you know, you need to actually initialize the credit card processor. Now, I did not know this. Like, this isn't written in the API anywhere. It's just kind of something you have to know on a project, because the credit card is secretly talking to the credit card processor. So you said, okay, no problem, I'm going to initialize it. You run a test again, and then the same thing happens somewhere else. So you go back to the first person and you say, okay, it's still not kind of working. And the guy says, well, yeah, I don't know. I wrote the credit card processor, but I wrote the credit card, but I didn't write the credit card processor, so I have no idea. You go talk to the other guy. So you go to that person and you say, okay, well, I'm having an exception. Help me out over here. So they kind of look at it and go like, yeah, well, the reason why it's not working because you forgot to do offline queue start. And I said, well, how am I supposed to know that, right? It doesn't say so anywhere. And the same story repeats, like only if we had documentation, the world would be a better place. But it isn't. And you don't need the documentation. I'll show you why in a second. So you run this, and of course it doesn't work still. And this story repeats over and over and over again for a long time until you finally figure out that you forgot to initialize some random objects all over the place. And you don't know why these objects need to be there. They just have to be. So what's happening is that the API is lying to you, right? It says, all I need is a credit card number, and I'm going to magically work. When in reality, the API actually has these secret dependencies on all these other places. So now notice over here, at some point, you make the test work, and maybe this isn't a test, maybe this is production code. And at some point, you look at the red area and you look at the green area, and you say, okay, I don't see how the two pieces are related. I'm going to refactor them. I'm going to move the red area over here, and I'm going to move the green area over there, because I think they should be apart. And then I'm going to change the order, and I'm going to call the first half earlier before the second half, because I think you should be able to rearrange this. And guess what? These two things are not interchangeable. But it's not clear by looking at this code that these two pieces are not interchangeable. So I'm going to ask you, how is your initialization in your application that you're building? Is it some of the friendliest code you've ever seen, or some of the scariest code you've ever seen? I'm going to say it's some of the scariest code you've ever seen. Do anybody like to disagree with me and not use it? And they're not using Jews, because that's not fair. Right, the code is scary, and the reason why it's scary is because usually the initialization code kind of grew organically. There was no rhyme or reason why I have to initialize this piece before that one, or it just kind of organically grew to some particular way. And then you want to add a new piece to it, and you want to globally initialize it, and you just randomly try, like, let me see if I can initialize it here. No, it's not going to work because it has dependencies on all these other things. So I got to pray and play around with these things and experiment, and then maybe finally it kind of works, and you say, don't touch it, and you check it in. And then the next guy comes along and he has to do the same thing again. So what can we do? We kind of already talked about the order of initialization. What can we do is, what we can do is we can make the APIs be truthful, and we can make the APIs say, look, if you're going to make a credit card, I need a credit card processor. I'm just coming out and saying it. I'm not secretly going to talk to some global state and get a hold of a credit card processor. I'm going to just come out and say, I need a credit card processor. Now I have a choice. First of all, notice I don't need documentation. I don't need to go somewhere and I don't need to ask anybody and say, hey, why is this not working? I know why it's not working because I need to provide a credit card processor. And now I have to have a choice. I can either make a real credit card processor or I can make a mock and put it in there. Or maybe I'm going to try with the null, see if that works. Sometimes that works too. When I try to instantiate a credit card processor, it says, well, I need a queue. And again, I have the same choice. I can say, well, I can make a real queue, I can make a fake queue, I can maybe pass in a null, maybe that's going to work. I have choices over here. I don't need to read documentation. And similarly, the queue says, well, I need a database, and so on. And you can kind of build up your whole objects that way. Notice that from a testing point of view, now you have a lot of choices. I can decide to mock the thing with an in-memory database. Maybe I want to mock it into a fake credit card processor. Maybe it's a credit card processor that doesn't really process anything. It's like a null fake one, right? Or maybe it's one that we use for testing, which is a simulator of the real one. You have choices here. Choices which you did not have when you had global state and singleton. And so this greatly adds into simplicity of the design of your application. It also makes it a lot easier to maintain. It also makes it that your initialization code becomes a lot friendlier because you cannot initialize this in the wrong order, right? Because if I try to change the order of initialization or instantiation here, the compiler is going to complain and say, look, you can't make a credit card processor before you made an offline queue. It just doesn't work the other way. You get a compile time error. So you get a lot of benefits over here by simply declaring the dependencies. Now what usually happens is people hear about this, they go back to their desk and they take a class and say, okay, I'm going to declare my dependencies. And next thing they know is they have a method, they have a constructor that takes 20 arguments and they say that can't be good. I think this whole dependency injection stuff is bogus, doesn't really work. Well, the reason why you have 20 dependencies is because your class actually has 20 dependencies. And what happened in the past is that you were pretending that you had a clean API. You were in denial. You were saying, it's actually quite clean. Look, it's constructor, doesn't take anything, it's all no problem. But the dependencies were still there because you couldn't just call the constructor and execute anything. You had to initialize all these magical variables all over the place. Now all I'm saying is, look, I just made it truthful. I just make it not lie. I just made it tell you the truth, that this is what it is, so deal with it. Now, at that point, people should really just say, yeah, a class should not have 20 dependencies, and maybe they should go in and say, well, maybe this class should be broken down into other pieces, or maybe the way the code is designed should be done something else with it, right? At that point, you have an incentive to go back and say, something's not quite right here, I need to rearrange something, right? But when the APIs are lying to you and everybody's pretending that the world is a wonderful place, not so good. So let's do some more examples of fun stuff. Suppose you want to test the account view, and the account view in your constructor goes and reaches in the global state, right? RPC client.getInstance, that's what it is. I mean, you can call it a singleton, you can call it a service locator, you can call it whatever you want in your application. It's still a global state. And the funny thing about global state is that it's transitive, right? So not only, some people say, well, I only have a singleton, it's called the service locator. And the service locator knows about the whole world. We'll talk about it in a second. It's still the same problem. Again, testability, not so good, right? What we're really after here is we want the user. So from a compiler point of view, when you try to compile the class, all you really want is user, but you have a dependency on RPC client. And the RPC client probably has dependencies on a whole bunch of other stuff that you don't care for. So not only are you asking for the wrong thing, you're lying about your dependencies, but the compile time dependencies are a lot bigger than they should be because the compiler dependencies are transitive, right? So we can test this. Again, we'll do our magic dependency injection, and voila. Now the account view depends on a user. And guess what? User is something I call the value object, right? Something that probably doesn't have dependencies on much else. And so user is probably something that's easy to instantiate, whereas RPC client, probably not so easy to instantiate, right? So if I'm going to mock out an RPC client, I'm going to have a hard time. But if I wanted to mock out a user, well, why should I mock out a user? I can just use the real thing, right? It probably just has getters and setters on it. I forgot what this example's about. We'll just skip that because we're running out of time anyways. Okay, let's talk about service locator and the law of Demeter violation. Somebody was asking what a law of Demeter violation is. I looked it up on Wikipedia once and I forgot what exactly it meant, but it apparently has to do with some god, Demeter or something? No? Yes? Okay. It's on Wikipedia, look it up. But really what it means is that you do too many dots. Let me show you. It really means that you have something like a service locator dot, get factory dot, get RPC client dot, get instance dot, get me the user, where all you really wanted was the user, right? You're kind of you're going through a lot of dots to get to your user, and we call it the law of Demeter violation. It usually comes into play with service locators. Now, I'm going to say that service locators are much better than singleton because at least you have one place where all the mess is, as opposed to all the mess being all over the place, but you still have a mess. So let me show you how this stuff hides dependencies. Suppose you have a house, and a house says, give me the service locator, or what are the other names for this thing? The manager, what else people call the service locator? Registry, yes. There's lots of names for this, same exact thing. So now you wanted to test a house, and you wanted to know what you have to mock out inside of the locator. Well, guess what? You don't really know. You kind of have to look at the construct to see what's inside of it. And so what usually people do is they create a mock locator, and they run the test, and they see null pointer exception, and then they see, aha, I have to mock out this method over here. And then they mock that out and run it again, and then they have to mock this method over here, and then so on and over again. And then you end up with what I call a mockery, where you have a test which mocks out 50 methods, and by the time you mock out the 50th method, you have no idea what you're testing, and half the time you even forget to put the assert on the end. So you are just verifying that you can mock it. I guess you're verifying the JVM, which I guess is a useful thing to do. Right, so notice the difference. If the locator needs to have the door, window, and roof, I cannot tell without actually looking at the source code what those dependencies are. But there's something worse over here, and that is locator is typically a class that has methods such as, get me service A, get me service B, get me service C, and so on. So the compile time dependency becomes, in order to compile the house, I have to compile the locator. In order to compile the locator, I have to compile the whole world, right? And once we are on compiling the whole world, it makes it very hard for me to reuse the code because I can't give the house to my buddy because he will need the locator, and with the locator, he'll have to get the whole world, right? So the compile time dependencies are usually a good giveaway that something is backwards. Now, we can simply rearrange this and say, hey, just give me the door, window, and roof. And all of a sudden, the compile time dependencies are greatly diminished. And the whole thing is much simpler. So your test becomes, hey, I can make a door, I can make a roof, I can make a window, and pass it in there. Now, I have choices, right? Here, I can say, well, make a real door, or make a fake door, or make a door that's configured in a particular way, just like we're configuring the cache. And it's all about having choices. It's all about setting up your software in such a way that inside of your tests, you can configure it in lots and lots of different ways so that you can bring out the corner cases that you're interested in. So the service locator is really mixing the responsibilities, right? Because there's a responsibility of lookup and also the responsibility of factory. Because the service locator oftentimes not only gives you handle to other objects, it also is the source of other objects. Right? It also calls the new operators in there as well. So really, the service locator tends to be this garbage dump of all kinds of random things. And usually, if you are lucky to have an interface for it, if you want to instantiate the real one, usually the dependencies for the service locator are pretty scary. And usually inside of your test, it's usually next to impossible to instantiate one of these beasts. So it's not really helping anything, really. It's kind of helping, but not really. Oh, we talked about making a mockery here. Let me kind of show you the issue here. This class seems to behave properly and says, well, look, I'm a login page. I'm going to do no work in a constructor. I'm going to be all good about it, like Miško said so. Here, I'm going to ask for RPC client, and I'm going to say I need HTTP servlet request, and I'm going to properly assign them into a fields. So you look at the constructor, you look at the fields, and you say, good, so far the class seems testable. But then you look at the login page, and you realize, wait a minute. the login page doesn't actually care for the request, nor does it care for the client. What the login page wants is a cookie, and really what it wants is the authenticator so that it can call the authenticate method on the authenticator with the cookie. So notice how we're breaking the law of the meter, right? It's really client.getAuthenticator.authenticate, which is what we're interested in. So we have two things in front of us, the client and the authenticator. And we have request.cookie, which means, again, we are jumping across a dot that we don't want. So if you count them up, I think there's 3 or 4 dots that are really in your way. The reason why this is a problem is because from a testing point of view, the test becomes really scary. You have to make a fake authenticator. Then you have to create probably a mock for it. Then you have to train the authenticator to receive the create method, or what was it, get, I think? The get authenticator method on it. You have to train all this behavior. You basically have to train all these mocks so that they can walk the dots. Only so on the end of the whole thing, you can call the authenticate method with a specific cookie, right? So what you really are interested in, here's a cookie, and there's the authenticator, and if I call the authenticate method, something good should happen. But what I really have to do is create all these other irrelevant objects, set them up in a specific way, train them through the mocks so that I can walk the dots, and then I can write my test. So if you look at this test, it looks pretty scary. Now, this is a test. It only fits on one slide. In reality, I have seen tests like these which span pages and pages and pages. And you have no idea what's going on after a couple of pages. Well, after a first page, I think, you have no idea what's going on. So how about we change this and we say what this class really wants is a cookie, and what the class really wants is an authenticator. Now, some people at this point usually say yes, but you see, the HTTP server request you passed in, that returns a different cookie depending on when you call it. And we come to a second problem, which is that chances are that the class has the wrong lifetime. Chances are that the login page shouldn't have a singleton lifetime or a single instance in your application, but rather a new page should be created with a new cookie over and over again. So a lot of times, the root cause of the service locator, it often happens to be that the objects have a much longer lifetime than they should have. Okay, so this becomes much easier, and look at this. The test now becomes much simpler as well, because you can just say, make me a cookie, make me a fake authenticator, and call the login on it, and then authenticate and verify that pieces are working, right? Piece of cake. The test becomes a lot simpler, and all we really did is removed a couple of dots, right? The dots are what we call the law of Demeter violation. Okay, wow, I have raced through this. I thought I was going to have a lot more slides than this. Questions? I think there's a Dory page, so I am going to see if I can get it up. No, that's not Dory. Is there a link to it? Yeah, you said, let me see if I can.
Actually, has anybody experienced some Dory problems? I guess apparently Prometheus is down.
A Dory question?
So I wanted to talk to you about it some.
Oh, no questions. Yes, live questions. Somebody had it on the VC? Could you grab the microphone?
What you're saying about not doing work in the constructor, it makes sense, but also I see a problem where, like, after the constructor, the instance is not ready to use in some cases, so you have to do something to it, and that would be the same thing, something hidden in the API that you have to instantiate it and then call initialize or whatever. Do you have a what do you say, idiom for doing that?
So the people actually ask this question quite a lot, and the example I usually give is that, hey, you instantiate a cache, but then you have to initialize the cache. So usually there's like an init cache method or something like that. But really what it means is that you should really be having a cache factory class and then a cache. And when the cache gets constructed, it is constructed in its ready state. And that method for initialization really should be inside of your cache factory. So for example, if the cache gets pre-initialized by reading stuff out of a database, then a cache factory should really be the one opening up the database, sucking all the data in, getting it all ready, and then once the data is all ready, then simply call the constructor and pass in the hash map with the set already so the cache is ready to go. So whenever you get in a situation like that, all you really are saying is that the initialization should be moved up one level and usually end up in a factory. Yes.
Hi, this is microphone way up here in the front. Okay, so you were talking about these constructors where you end up with 20 arguments in the constructor, and then you need to break it up. Do you have any advice on, I mean, what do we do when we get to that situation we need to break it up? I mean, those 20 arguments need to go somewhere.
Right. So it's a sign that there's something wrong with the design. And usually what it breaks down to is that the class has too much responsibility. And usually if you look at those constructors, you kind of look at them and you go like, oh yeah, these 4, they deal with sending emails. And these 3 over here, they deal with authentication. And these 4 over there, they deal with the persistence layer, right? And so what you really are saying, oh, I could build another object that abstracts those 3 over here that deal with authentication into a higher level concept like the authenticator. And I can take these 4 over here and I can wrap them in something like a mail server, right? And so what you're doing over there is you are simplifying the world by taking related pieces together and building a higher level object that probably is begging to exist. Because usually that logic has to live somewhere, but chances are you just inline the logic into a higher level class. So what I'm saying is you create a new class that has the related stuff, and then you take the logic which should really been there to begin with, and you just move it down there. So then you have only, the number of dependencies are decreased through that trick.
So is this just going to make a long initialization chain then, where
the initialization chain is actually the same. You're just moving where things are. Because you always have the same number of end nodes that need to get built, right? That's not changing. You're just saying that there is now better grouping going on, so that there's more objects that take related things together and produce or present them as a service to other objects.
But these new objects, the authenticator and the emailer and so forth, might only exist for the purpose of constructing this
That's
object.
okay. That's absolutely okay. Chances are they actually won't. I mean, in your example, you're saying that they could, and I'm saying it's okay. But you're actually going to discover that if things go together, they go together throughout the application. And you'll actually discover that it's the same thing that happens in other places. And you're going to say, oh, look, I have this object. And then you realize, wait, the same thing's happening here, here, and there. And so all I now have to do is pass the single object over there, and I don't have to pass these 3 individual ones.
All right, thanks.
Sure. Yes.
So I see a common pattern here. So whenever you require some instance to be created inside the class, you try to create it outside and pass in as a new parameter in your constructor function. But in some scenario, as in our real application, we found a case where, for instance, this kind of the change for make code testable, however, will change the format of your original constructor function. But in our real cases that we found it doesn't work with the register pattern, where you have many subclass which all require the same form of a constructor function. So basically they all take the some config, let's say some config string as the input, then they do something inside. So how this thing will work?
I think I followed you until you said the word config.
Right.
What do you mean by config? They take the same...
let's say you have many classes and they all need to be registered with some kind of register factory. Right?
Okay, so first of all, we already covered the fact that you shouldn't have register or factory, right? Because that's bad. But go on. Okay.
So then, yes, basically that's my question. So then each class now taking the different config. Each class can take a different config string as their input.
So when you're saying that you're passing around config string, what you really are saying is that you're pushing the responsibility of extracting information out of the configuration into the classes.
Right, yes.
And I was just kind of trying to argue that you shouldn't do that because that makes it really hard to test. Okay. Now, sometimes you get in the situations where the object as lifetime are different. So you have a single class who has a long lifetime, but it needs to create lots of small ones. So you cannot inject the short-lived object into the long-lived object. So then you have to inject a provider, right, or a factory. So if you're in Juice World, you say the provider of that object. If you're in a factory, then you just create some object factory class that you inject in there. And that gives you the ability to kind of wire them up any way you want. It's not kind of answering your question, I know,
Right.
because your question is a little different,
Right.
but I think we would have to sit down and draw it out, and I will
Right,
show
right,
you
right.
how these things would melt
Sure.
away.
Maybe I can talk to you after.
Sure, you can do that. All right, guys, you've been a great audience. Thank you so much. Do we need anything else, or are we good? All right. Thank you very much for coming. If you have questions, send them to me. It's misko@google.com. And see you later.